Alright, so this is a problem from chapter 6, and the question is, when the driver applies the brakes of a light truck traveling 10 kilometers an hour, it skids 0.5 meters before stopping. How far will the truck slide if it is traveling 80 kilometers an hour when the brakes are applied? So there is a way where you can completely bypass the work energy principle, but for the sake of this video, I'll use the work energy principle. So for the system, I used the truck and the earth. This way I can have where work equals zero, well, work equals the change in energy, and so I can set work equal to 0 and solve for the change in energy. So firstly what I did was I converted the velocities into meters per second, and I drew all forces acting on the object. There's going to be force of friction applied, which was not given, the velocity in the positive x direction, gravity, and the normal force. In this scenario, they don't give mass or time, so it would be very hard to solve it. It would be very hard to solve using the momentum principle, so that's why I chose the work energy principle. Since the work energy principle does not require time, so that limits only one factor of unknown. Excuse me. Um, Also, the truck is traveling in the x direction, and both force due to gravity and normal force are acting perpendicular to its path. Therefore, no work is being done using those two forces. So the only force contributing to work would be the initial velocity and force of friction. So basically, what we're looking for is uh, how long how long will the truck stop going 22 meters per second? Um, so once again, this is the work energy missile. So work equals change in kinetic energy plus change in potential energy. There is no change in potential energy, so it's just work now equals change in KE. Change in KE is 1/2 mv final squared minus 1/2 mvi squared. And this was very important in this diagram. So the force of friction, it's in the opposite direction of the displacement, so it's negative, and it's with that's why 1/2 mv initial squared minus force of friction equals 1/2 mv final squared. And it's all the force of friction. You get 7.716 times the mass. The mass in the problem was not given, so I was hoping that just canceled out when I tried it the second step. This first stage was for the 2.778 meters per second. Now this is where you actually solve the distance it would require for it to stop going 22 meters per second. Once again, the work energy principle, and the only different thing you do here is for force of friction, you actually plug in 7.716, and the calculations turns out to where both the masses cancel, and you're left with S equals 31.1854 meters. Now to check this, there is a velocity squared function where basically if you relate the two velocities, one second right here, the two velocities, so going 80 kilometers an hour and 10 kilometers an hour, it's a factor of 8. So if you square that, you get 64. That means that it would take 64 times more for the second velocity compared to this. So for instance, if this is going 0.5 meters per it would take, if this takes 0.5 meters to stop for going at this velocity for 10 kilometers an hour, it would take 64 times that to stop it at 80 kilometers an hour. And 0.5 times 64 is pretty accurate to this. So thank you.